Trigonometry today. So the very first thing that I want you to do is just to figure out your calculators again. So just make sure you know how to do it on your calculator. So what's the sine of 45 degrees? So just punch that in your calculator. It is. This would be called its exact value. So if it asks for the exact value, we would want it as a square root. But if we wanted just an approximation or a number that would make more sense in our head, then what is the decimal point number for that?
If you hit your little arrow keys down at the bottom.
0.707 if I have that one memorized correctly, right? Yeah. So these both are the same answers. This one would just be called the exact value, and this one would be an approximation. I don't really care which way you leave it, except for when it asks you to leave it a specific way. When you get into my Math 3 class next year, you will have to leave it in radical form like this. Okay? Those of you that are coming back. All right, cosine of 30. Punch it in and tell me what it is. Square root of 3 over 2. Or if you go decimal point number, 0.866. Okay. Questions on how we're getting that? Everybody's okay punching it in their calculator? Yeah. Tangent of 15 degrees.
Negative square root of 3 plus 2.
Or
It's only plus 2, not over 2.
That's, punch it in one more time. All right, let me write it different. I thought that's what you said. You said negative square root of 3 plus 2. Okay. Or if you hit your arrows.
You forgot the negative.
Thank you. Or if you do it as a decimal point number, what is it? 0.26. 7. 0.267 or 0.27?
0.2679.
Oh, so 0.26. Yeah, at some point we have to find a place to stop and round to, right? Okay, so either way, again, this is your exact value. This would be your decimal point approximation. Okay. All right, so this time it says, how do you undo a sine, a cosine, or a tangent function? Well, you must do the inverse of that function. If you guys take a look at your calculator for just a minute, and you look above the sine key, what key do you see? The sine -1 key. This is called the inverse sine function. This would be called the inverse cosine function. This is the inverse tangent function. It undoes the original. Just like on our calculator, if we square something, what undoes a squared? The square root. So if we want to undo one of these trig functions, we're going to use that undo key, which is really the inverse function key. So do you see right here where I have the tangent of an angle equals 4 over 5? Well, what if I want to know the angle? I would undo the tangent, right? Because I'm really just trying to get that b by itself. So how do I undo a tangent? I do the tangent -1. So I'm going to do the inverse tangent of 4 over 5. That's going to tell me my b value, my angle value. So just punch that in your calculator, hit that second key to get to your tangent. Do 4 over 5.
I got 38.65.
Yeah. And if you're rounding that to 2 decimal places, that would be 38.66, right? If you're rounding to 2 decimal places. I'm going to put the degree sign there because guess what we just found? The angle measure of angle B, right? Because do you remember how the formula says the tangent of the angle equals the opposite over the adjacent? That's the rule, right? So what were we looking for there? We were looking for the angle measure. Okay? So over here, I'm looking for the angle that if I took the cosine of it, I would get 5 over 8 for my answer. So how do I undo that? I do the cosine -1 or the inverse cosine of 5 over 8, and that's going to give me the measure of angle A. So what did you guys get when you punched that in your calculator?
51.31.
Say it one more time.
51.31.
Thank you, 51.31. And again, I'm going to put my degree symbol on there because we're talking about an angle measure. Okay, does everybody agree with that answer? I didn't check it. We're good? Okay. One more then. How do I undo a sine? I use the inverse sign to find that angle. So I would do the inverse sine of 3/2, and that would give me the measure of angle theta. When you do that, what do you get theta equal to?
Domain error.
Oh, what? What does that mean? What does it mean if you get a domain error on your calculator? Yeah, it means no solution, you guys. It means it's not possible to have an angle that would give you 3/2 as the sine of it. Okay? So empty set would be your solution, meaning there's not an angle that would work. Okay? Questions on how we did those three, just doing the inverse sine, cosine, and tangent functions. All right, so now we're going to see if we can solve for some missing angles then. So before today, we've only solved for the missing sides, right? And now I want to find the missing angle. Well, I know all three of the angles in a triangle add up to 180 degrees still. So if I had one more of them, couldn't I just subtract two of them to find the third one from 180 degrees? So I'm going to look at angle A because that's the first one that they asked me to do. I'm going to look from angle A and I'm going to see if I can write myself a trig function to solve for angle A. So from angle A, they gave me the opposite and they gave me the adjacent. You're right, opposite and adjacent. This one has to be the hypotenuse from angle A. That's the way I would label it. So which of my trig functions uses opposite and adjacent? Tangent. So I'm going to write a trig function. I know that the tangent of angle A, because I don't know what A measures, right? That's what I'm looking for. The tangent of angle A equals the opposite, which is 5, over the adjacent, which is 15. Now, yesterday we did this a lot. And the day before we did this a lot. But today we're going to go one more step to find the angle. Anybody remember how I just showed you how to do that? How do you find the angle? You undo the tangent. How do you undo the tangent? You use that tangent -1 key or the inverse tangent on your calculator. So you have the tangent -1 of 5 over 15. That would be, say it one more time. 18.43 degrees. Do you guys agree with that?
Yes.
So I just found this angle to be 18.43 degrees. How easy does that now make it to find angle B? Yeah, because what do you know all three angles in a triangle add up to be? 180. So take the 180 minus the 90, which we know would be 90, and then minus the 18.43. And what do you get for angle B? I love that you guys all shouted that answer out at me. That means you understand what we're doing here. Nice job on that, you guys. So the measure of angle A up here at S, the measure of angle A would be 18.43 degrees, and the measure of angle B would be 71.57. So again, still using trig functions to set up. But instead, when we're looking for the angle, we're going to do the inverse trig function in order to solve for it. Okay? All right, so this next problem right here, it says find the measure of angle X. So here's my X right here. Help me label my triangle from that spot. So here's my opposite, which I didn't use. This is my hypotenuse, and this is my adjacent. So I have the adjacent and the hypotenuse. Which trig function is that? Cosine. So I'm going to say the cosine of angle X equals the adjacent over the hypotenuse. You guys okay with how I set that up?
Yep.
Okay, how do I find the angle? I have to get rid of the cosine. How do I undo a cosine?
Cosine
I do, yep, the inverse cosine on the calculator. So I do the cosine -1 or the inverse cosine of 109 over 134. That will be equal to my angle. 35.56. You guys agree with that? Okay, so what's the measure of angle X? The angle X measure is 35.56 degrees. Now, could I totally go and find my other stuff from there? I can. This problem didn't ask me to, but guess what my next problem does ask me to do? Solve for every part of the triangle. It says find all the angles and all the sides. Okay? So, pretty simple right here to find the third angle. Would you agree with that? Yeah. So, what's this third angle going to be? I can find it by doing 180 minus 90 minus 62. So how much is this angle? 28 degrees. Now I'm missing 2 of my sides, so I'm going to have to set up at least one trig function to find one of the other sides. After I do a trig function, then if I have 2 of the sides, I could use the Pythagorean theorem if I want to, or I could set up another trig function. So which angle do you want to look at, the 62 or the 28? The 28? Okay, from the 28, what would this side be called? The adjacent. And which one do you want to look for, the opposite or the hypotenuse? The opposite? Okay, if we're going to do what Jordan said and look for the opposite, which trig function would I use for opposite and adjacent? Tangent. So I'm going to go the tangent of 28, because this time I have the angle, right? So this is like yesterday's work, equals the opposite, which I don't know, over the adjacent, which is 25. Now this is a simple cross multiply and solve problem. So put the 1 underneath there, cross multiply this direction. You're going to have the tangent of 28 on your calculator. Close your parentheses and times it by 25. When you do that, what do you get for your x value? Awesome. Okay, so this side is 13.29. So now I have a choice right here of how to find this third side. This is the hypotenuse. I can go a squared plus b squared equals c squared, or I can look from my angle and set up another trig function. It's your choice. Which one do you want to do?
Would you repeat that?
Do you want to do the Pythagorean theorem, or do you want to set up another trig function?
Just do another trig.
Let's do another trig function. Should we look from angle 28, because that's how we always already have it labeled from?
Sure.
So what am I looking for then? I'm looking for the hypotenuse. Now I have to decide if I'm going to use the adjacent or the opposite now, because I have both of them. So I kind of always like to use the one that I started out with, just because it's usually cleaner to look at, but you could choose whichever one. But let's use this one because it's there and it's beautiful. So if I'm going from angle 28 and I'm going to use the adjacent and I'm looking for the hypotenuse, which trig function am I going to use? Which one uses adjacent and hypotenuse? Cosine. So I'm going to say the cosine of the angle. Anybody remember what angle we were looking at? 28 equals the adjacent, which is 25, over the hypotenuse, which I don't know. I'm just going to put h there. Now this one's just like the bell work. So if you remember how Mr. Wilkes showed you how to do it on the bell work, do you remember the shortcut on how you would do this one? I'm going to write it out. This direction, like Mr. Wilkes showed, would be the cosine of 28 equals 25. And I forgot my h here, times by h. How do I get h by itself? I would divide by the cosine of 28. So if you want to do it as just one step on your calculator, you would do 25 divided by the cosine of 28. And what do you get when you do that? Yep. Now, there's a pretty quick and easy way to just see whether or not you are on target with your hypotenuse. The hypotenuse has to be the longest side of the triangle Is it the longest side of the triangle?
Mhm.
Yeah, so probably I did my work correctly. Another way to figure out whether or not you did your work correctly, though, would be to do a squared plus b squared and see if it equals c squared. If that works, then you did your work correctly also.